Okay, the EMF and internal resistance, part 3 of 5 on electric circuits. Okay, so the EMF, known as electromotive force, is the maximum energy or the maximum work done per coulomb or per unit charge that a battery can supply. So you are going to use what you are comfortable with. You can say maximum energy or maximum work. You can say per coulomb or per unit charge. So this definition matches with this formula, the formula for potential difference. Okay, potential difference is equal to the work done over the charge. Okay, EMF is a potential difference or a voltage, but a maximum. Okay, so a maximum potential difference or a maximum voltage is known as EMF. Okay, we are going to see that. So this definition matches with this formula. Okay, so if you buy a battery as this one, you are going to see on the battery there is a voltage indicated. So for example, you have 12 volt. This is the EMF of this battery indicated on the battery. Okay, if you buy a cell as this one, on the cell you are going to see that there is a volt indicated. This is the EMF of this cell. Okay, 1.5. This is the EMF of this cell. So EMF is the maximum potential difference or the maximum voltage. Now, the EMF and potential difference are closely related, but they are not the same quantities. Okay, the EMF is the maximum potential difference. Now, the term voltage can be used in place of potential difference or EMF. So this is a voltage, this is also a voltage, but this is a maximum voltage that a battery can supply. Okay, so you understand. Now, in a circuit, the EMF is the potential difference or the voltage when no current is flowing in the external circuit. Okay, when no current is flowing in the external circuit. So you have a circuit and you have the main switch is open. So no current is flowing when the switch is open. So if you use a voltmeter across the battery, you are going to read the EMF. Okay, so the main switch must be opened for you to read the EMF. Okay, you have the main switch opened. Now with your voltmeter across a battery, you can now read the EMF. In the example on the left side, the EMF is 3 volts. Okay, 3 volts. Okay, now when the main switch is closed, okay, when the main switch is closed, the voltmeter reading drops. Okay, you have the main switch is closed. Now the voltmeter reading drops from 3 volts to 2.8 volts. Okay, so this voltage drop, okay, this voltage drop is due to the internal resistance of the battery. The battery has got an internal resistance. Okay, the internal resistance of the battery is using some of the energy per coulomb, okay, within the battery. So some of the energy per coulomb, they are used within the battery. Okay, so this voltage drop is due to the internal resistance of the battery. So the internal resistance is the resistance within a battery. All batteries have got an internal resistance. Okay, the voltmeter reading after the switch is closed is the potential difference or the voltage supplied to the load. This is the potential difference or the voltage which is supplied to the load. Okay, 2.8 volts is supplied to to the load. The load is anything connected to the battery. Okay, anything connected to the battery is the load. Okay, so we carry on. The load. Now, the load can also be referred to as the external resistance of the circuit. External, meaning outside of the battery. Okay, external. Internal, meaning inside of the battery. So, for internal resistance, we use lowercase r. For internal resistance, internal, inside of the battery. External, outside of the battery, we use uppercase R for the external resistance. Okay, you can have 1, 2, 3, and more resistors connected to the battery. So, the potential difference or the voltage supplied to the load, this potential difference or the voltage which is supplied to the load is known as external potential difference, or you can say external voltage, or you can say terminal potential difference or terminal voltage. Okay, so initially you are inside of the battery. Okay, your initial point. Now your terminal is outside. Okay, this is how you can remember. You can also call the supplied potential difference or the supplied voltage as the load voltage. So this is the effective output or the effective supplied potential difference or voltage to the load or to the external resistance. So in the example on the left side, the external potential difference or the external voltage is 2.8 volt. So the voltage dropped by 0.2 volt. Okay, from 3 to 2.8, you have 0.2. This is known as the lost voltage or the internal voltage. This is inside of the battery. So we know that the EMF is equal to external voltage plus internal voltage. External voltage outside of the battery, internal voltage inside of the battery. Okay, so the EMF is equal to, remember this formula, voltage is equal to current times resistance. Okay, so voltage is equal to current times resistance plus, now you have internal voltage inside of the battery. You're still going to use the same formula. You have current. Now for resistance, you are going to use the lowercase r for internal. The uppercase R is for external resistance. Okay, external resistance. For internal resistance, we are going to use, for internal resistance, we are going to use the lowercase r. Okay, inside of the battery. The EMF is equal, you have current is common, so you are going to take current outside of the bracket. Okay, you factorize, you have uppercase R plus lowercase r. Okay, this is the formula for the EMF. Okay, now in the example on the left side, the EMF, we're still going to use this formula. Okay, external voltage plus internal voltage. This is equal to, for the example on the left side, the external voltage is 2.8 plus the lost voltage or internal voltage, which is 0.2. You are going to have 3 volts. So to calculate the EMF, use external and internal resistances, uppercase R and lowercase r. So you are going to have this. To calculate the external voltage, you are going to use only external resistance, uppercase R. So for external voltage, you have this, okay? This. Now, to calculate internal voltage, okay, inside of the battery, you are going to use the internal resistance, lowercase r, okay? For internal voltage, you have current times lowercase r, okay, inside of the battery. Now, the formula of EMF. This is the formula as we saw previously. So, whenever the external voltage is increasing, the internal voltage will decrease. This is always the case. Or whenever the external voltage is decreasing, the internal voltage will increase. This is in order to keep the EMF constant. You cannot have both external voltage and internal voltage increasing, or you cannot have both external voltage and internal voltage decreasing. So you have to remember the EMF is always constant, and as the external voltage increases, the internal voltage decreases, or as the external voltage decreases, the internal voltage increases in order to keep the EMF constant. Now, the internal resistance of a battery. Let's see about the internal resistance of a battery. The internal resistance, lowercase r, okay, the internal resistance of a battery is one of the parameters that indicate the ability of a battery to carry current. A brand new battery has a low internal resistance. So when the value of internal resistance is low, the battery is going to carry a significant amount of current. So a battery with a low internal resistance will have a low lost voltage or a low internal voltage. As a result, you are going to have the output or the supplied potential difference or voltage is going to be high. So you have a higher output of voltage. So this is the external voltage, which is high. We can understand this using the formula of EMF. Okay, let's see. From this, we know the external voltage is equal to, you have EMF, you take internal voltage to the left. Now you have EMF minus internal voltage. EMF minus internal voltage. Remember, we have EMF constant, always constant. Now, when the lost voltage or the internal voltage is low, decreasing, so from the EMF, you are going to subtract a smaller number. You end up with a higher external voltage. So now this is about a brand new battery. Okay, what about an old battery? So over a long period of time, the chemical reaction inside of the battery will slow down due to rust and corrosion inside the electrode of the battery. So as the chemical reaction slows down, the internal resistance of the battery increases. This is why an old battery will have a high internal resistance. So a battery with a high internal resistance will have a high lost voltage or a high internal voltage. So as a result, the output or the supplied potential difference or voltage is low. So the external voltage is low. Okay, let's understand this using the formula. Okay, from this, the external voltage is equal to EMF minus internal voltage. Okay, so EMF is always constant. So now you have a high lost voltage. Okay, a high internal voltage. So can you see you have a large number subtracted from the EMF? You are going to have a smaller number. So we are going to always assume that the internal resistance of the battery is constant. Let's solve a problem from past exam. Okay, question 8. A group of learners conducted an experiment to determine the EMF and internal resistance of a battery. The data obtained from the experiment is used to plot points on graph paper and draw a line of best fit. The graph of one of the learners is given below. The x and y axes have not been labeled. Okay, we have this. Question 8.1. Explain the term internal resistance. Okay, 1 mark. 8.1. This is the resistance within a battery or within a cell. Now, 8.2. Write down one factor which must be kept constant during this experiment. Okay, remember Ohm's law statement requires that you have the temperature constant. Okay, so you need to have the temperature constant for Ohm's law. Okay, now using the graph 8.3 provides a label for the y-axis. 8.3 provides a label for the y-axis, 1 mark. You are going to have voltage on the y-axis and current on the x-axis. The highest point on the y-axis will be your EMF. Remember, EMF is the maximum voltage, or you can use the word potential difference. Okay, EMF is the maximum potential difference. Okay, so provide a label for the y-axis. This is going to be voltage or potential difference. So now 8.4. Using the graph, write down the quantity represented by the gradient. Okay, the gradient of this line when you have voltage on the y-axis and current on the x-axis, the gradient of this line will be the resistance. In this case, we are dealing with a battery. So this is going to be internal resistance. Okay, internal resistance. You can see. Let me show you. The gradient, okay, the quantity represented by the gradient or the slope of the graph. So you have voltage on the y-axis and current on the x-axis. So to find the gradient, you have change in the y. So in the y, you have voltage, okay, over change in the x. In the x, you have current, okay, change in the current. Okay, so this is equal to, remember this formula from Ohm's law. Voltage is equal to the current times resistance. So from this, resistance is equal to, can you see, you are going to divide by current on both sides so that you can have resistance. Now you have current and current cancel. Now you have resistance is equal to voltage over current. So voltage over current is equal to resistance. Now in this case, we are dealing with a battery. We know inside of a battery, we have internal resistance. Okay, so this is how you can find your answer to question 8.4. Let's carry on. Now, 8.5, using the graph, write down the EMF of the battery. So, you are going to read the EMF. The EMF will be the maximum. Okay, so you have to know each square represents how much. So, for you to find out, this is what you have to do. Between 6 and 8, the difference is 2. So, you have 2 divided by how many squares do you have between 6 and 8? Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you are going to divide by 10. Okay, you have 10 squares between 6 and 8. The difference between 6 and 8 is 2. So you have 2 divided by 10 squares. This is equal to 0.2. Okay, 0.2. So each square represents 0.2. Okay, so now you have to read. You start from 6, 1 square above, you have 6.2, 6.4, 6.6, 6.8, 7, 7.2. Okay, so you have 7.2 there when you read 7.2. So this is the maximum, the total. Okay, the maximum, the EMF. Okay, so the EMF is equal to 7.2 volts. Now question 8.6, calculate the internal resistance of the battery. The gradient of this graph will give you the internal resistance. So you can calculate the internal resistance using any 2 points on the graph. You can use this point and this point. Use the coordinates. Okay, you are going to use the coordinate. The coordinate of this point, you have 0.8. Okay, 0.8 and 0. Okay, 0.8 and 0. Y is 0, x is 0.8, and the coordinate of this point, you have x is 0 and y is 7.2. Okay, from 6 to that point, 7.2. Okay, so you can use any 2 points on this graph to find the internal resistance, because the internal resistance is the gradient. So you know, to find the gradient, you have change in the y over the change in the x. Okay, so you can find the internal resistance by finding the gradient of this line. Okay, so you have the slope or gradient. Okay, slope or gradient is equal to change in the y. This is the change in the voltage. Remember, you have voltage, okay, voltage on the y-axis and current on the x-axis. So you have change in the voltage over change in the current. You're going to have, you can use the 2 points, or you can use the change in the y, which is the change in the voltage. So from 0 to 7.2, the change is 7.2, over from 0 to 0.8, the change is 0.8. You are going to have 9. Okay, so the internal resistance is equal to 9 ohms, or you can use the coordinates. Okay, so or the slope is equal to change in the voltage over change in the current. This is equal to, using the coordinates, okay, using the coordinates, we can find the gradient, which is the internal resistance. So you have change in the y over change in the x. So let's start from this point going to this point. Okay, from this point going to this point. So what is your y? 7.2 minus, going to this point, what is your y? 0. Okay, you start from this point going to this point, change in the y. Okay, remember, the second coordinate is always your y. The first coordinate is always your x. Now, you have over change in the x. Okay, the first coordinate is always your x. The second coordinate is always your y. Okay, now change in the x. You have, we start from this point, 0 minus 0.8. Okay, you have to keep the order. When you start from this point with your y, you are going to do the same with your x. Okay, from 7.2 minus 0 over from 0 minus 0.8. You are going to have -9. So internal resistance is not negative. The negative is to tell you that this is a decreasing line. Okay, decreasing. This is why you have negative, because this is a decreasing line. So the internal resistance is equal to 9 ohms. Okay, we carry on. Now 8.7, the question says determine the value of internal voltage when the graph reaches 0.8 on the x-axis. Okay, 0.8 on the x-axis. The total current, okay, the total current, this is the total current, okay, 0.8. Determine the internal voltage. So the internal voltage is the lost voltage, okay, inside of the battery. So how much is lost? From 7.2, okay, 7.2 to 0. How much is lost when you reach 0.8 on the x-axis? You have 7.2 is lost. Okay, 7.2 is lost from 7.2, okay, from 7.2 to 0. How much is lost? you have 7.2 is lost. This is the internal voltage. Okay, so you can do this, or you can use the formula. Okay, the formula, you have the total current is 0.8. Okay, 0.8. The total current in the circuit, 0.8 times internal resistance 9. Okay, you are going to have 7.2 volt, which is your internal voltage. Okay, so we are done with this question.